This is the second video in the stoichiometry unit. The purpose of the video is to discuss using factor label method. The objective is that by the end of this video, you'll be able to use factor label method to perform unit conversions. In order to make your time with this video effective and useful, you're going to want to have the calculator present that you use on tests and quizzes, a pencil, and then either your notes or your capture sheet. To begin with, what is factor label method? Well, factor label method, sometimes called dimensional analysis, is going to be the problem-solving method that we use in chemistry. It's used in many other areas of science as well. The purpose of it is to have some organized way to solve problems based on what the units are that you have and that you're trying to find. A nice thing about it is factor label method helps you determine how to solve a problem when you're not sure where to start or where to begin with the problem. And finally, it's a method that uses conversion factors. Now, what's a conversion factor? A conversion factor is simply a fact. It's a relationship between quantities. It's two ways of expressing the same amount. You already know a lot of different conversion factors from prior studies. For example, 3 feet is equal to 1 yard. These are two things that are equal to each other. It's two ways of describing the same amount. It's a conversion factor. 12 eggs is equal to 1 dozen. It means the same thing. If you buy a dozen or 12, you're buying the same amount. And then 1 meter is 1,000 millimeters. It's two ways of expressing the same amount. It's just a different way of saying it. Can you come up with any conversion factors of your own? Okay, once when we know that, let's talk about how to use it to actually solve a problem. Now we're going to start with an easier problem first, and then eventually, once we learn how to use factor label method, we'll use it to solve chemistry problems that are more difficult. But to begin with, we're going to start with something easier. So a piece of string is 1.5 feet long. How long is this going to be in inches? Well, to solve this, you want to know that in general, you should always take whatever you were given, multiply it by the conversion factor to find your answer. So what's our conversion factor going to be? Well, we want to find the relationship between feet and inches. And you may remember that 1 foot, so 1 FT is the abbreviation for foot, is equal to 12 inches. Since they are the same thing, they mean the same amount, that's your conversion factor. So let's get started with using it. We need to start with a given. The given is the number they give you in the problem. So in this case, 1.5. Now, since the whole purpose is to use units to figure out what to do, we had to write down the units. So 1.5 feet. Then we're going to times that by our conversion factor. Now the question is, what do you do with a 1 and what do you do with a 2? And this is where the units come in. Whatever unit we have on top, that unit is going to go to the bottom. Let's say that again. Whatever unit we have on top, that's the unit that goes on the bottom. Always. Then let's look at our conversion factor. What number goes with feet? 1 goes with feet, so we're going to write down 1 foot down here. The rest of the conversion factor goes on top. The rest of the conversion is 12 inches. 12 inches goes on top. Now, before we do the work, we want to cancel out the units that we can. Any unit that's the same on the top and the bottom can cancel out. So feet cancels out, and we get an answer in inches, which is exactly what we want. Now, in your calculator, you're going to multiply across the top, and you're going to divide what's on the bottom. So 1.5 times by 12, get that answer, then divide it by 1. And your answer is 18 inches. Let's try another one. An index card is 5 inches wide. How wide is it in centimeters? Once again, we want to use our given, times that by the conversion factor to get our answer. But what is our conversion factor? What's the relationship between inches and centimeters? This is the kind of relationship we would be giving you. So we would tell you that 1 inch is equal to 2.54 centimeters. So now, using your conversion factor in the given, let's do the work. So starting with the given, the 5 inches. We want to multiply this by the conversion factor. But what should we put on the top and what should we put on the bottom? Now remember what we said earlier. Whatever unit you have on top, that's the unit that goes on the bottom. Inches were on top, inches would go on the bottom. So we're going to put IN down here. Then you look at the conversion factor. What number goes with inches? The answer is 1, so 1's on the bottom. The rest of it goes on the top, 2.54 centimeters. Now, before we continue, let's cancel out what we can. Any unit that's exactly the same on the top and the bottom can cancel. So inches is the same on the top and the bottom. We're going to cancel that out. And then in the calculator, 5 times by 2.54, then divided by 1. Always divide the bottoms. And you get an answer of 12.7 centimeters. And that is your answer. Now, in these two columns, we had 1 on the bottom. See? And you might think that, well, that must be a shortcut, that 1 always goes on the bottom. That's not going to be true all the time. Let's see one that doesn't work out that way. In this case, the maximum speed of a cheetah is 2,000 meters per minute. How fast is this in miles per hour? Well, the first thing we should think about is that in the past, we've always done given times by conversion factor equals answer. But the reality is, sometimes we need more than one conversion factor here in order to get to the answer. Now, we need to try to find a relationship. Miles per hour, right here, could be written as miles per hour. So miles and meters are both on the top. We need to find a relationship between miles and minutes. We also have to find a relationship between miles and meters, then another one between hours and minutes. Now, this is going to be a multi-step problem because let's say that what we know is that 1 kilometer is 0.621 miles. That can get us from miles to kilometers. Then 1,000 meters is equal to 1 kilometer. That'll get us from meters to kilometers. And then finally, going from minutes to hours, that relationship is 60 minutes equal to 1 hour. Now, right now, this looks kind of complicated and strange. How do we get started? Well, we get started by using the given. So let's write down the given. So we have 2,000 minutes per minute. Whatever we say the per is going to go on the bottom. And we're going to look at 1 unit at a time. So we're going to get rid of this meters somehow and try to eventually get into miles. So we're going to times that by a conversion factor. Whatever this unit is on top here has to go on the bottom. So let's do that first. Let's put the meters on the bottom. And taking a look at our conversion factors, do we know anything about meters? We do right here. 1,000 meters is equal to 1 kilometers. So 1 km on the top. Now, that's a start. But we don't want kilometers. We want our answers to be in miles per hour. So since we're not done, let's do another conversion factor. And what we know is that whatever unit's on top is going to go on the bottom. So we're going to do that next. Let's move that kilometer down to the bottom of the next square. km. Now, do we know anything about kilometers up here? Well, we have this 1 kilometer is 1,000 meters. But we already used that, so we won't use that again. We could go from kilometers to miles. Let's do that one next. So 1 kilometer, and 0.621 miles. That's the rest of it. The rest of it goes on the top. Now, before we continue, let's see where we are right now. Right now, we could cancel out the meters with the meters and the kilometer with the kilometer, and the answer, if we stop at this point in time, would be in miles per minute. But we don't want miles per minute, we want miles per hour. So let's do another conversion factor. And since the top part looks good, we want miles on the top, and we got miles on the top, let's look at the bottom. Now in the past, the units have always come down, so they can cancel. Well, now it's going to do the opposite. What's on the bottom is going to go to the top, so we can cancel it out. So let's put our minutes on the top. So minutes goes on the top. Now looking up at the top, what do we know about minutes? Well, we know 60 goes with minutes. So we're going to put those together. The rest of the conversion factor goes on the bottom. 1 hour. Now notice we do have a 1 there and a 1 there, but here the 1's on top. So it's not a shortcut to say that the 1's always go on the bottom. In our calculator, we're going to multiply across the top, and we're going to divide all the bottoms. So 2,000 times by 1 times by 0.621 times by 60, get that answer. Then divided by 1,000, divided by 1, divided by 1, and you get an answer of 74.52 miles per hour. Now you probably think you need some practice with this, and you will be getting practice with this in class, but take a look at what you're doing again. You always start with a given, and you can definitely recognize the given from your problem. Then you want to multiply that by one or more conversion factors. What are the conversion factors? The conversion factors are facts that you know about relationships. They're two things that are equal to each other. Then you always want to set it up so the unit that you have will cancel out with the next one. What you're going to find is, on these problems, it's all about getting started. You don't see the end until you're almost there.